Okay, real quick, mini lesson for you, just to get you prepped for tomorrow. There's no assignment associated with this. I just wanted to kind of point out to you these things that were on your reference table that I kind of pushed by a little bit. I just wanted to talk about them real quick. So, here we have a picture of a very simple diagram of a circuit. What we have is we have a situation where we would have current flow out of here, and it would flow through this guy. This is known as an ammeter. An ammeter is strictly a device that measures the current through a particular section of the circuit. So if I place it here, it would tell me how much current is flowing through this section of the circuit. Now, the whole idea behind a measuring device is to keep an accurate measure of what it's trying to measure without changing what's happening in the circuit itself. So, you see here it says it acts like a gate that allows current to pass through it while counting the charge as it flows. Now, because the device is connected as it is in the actual circuit and the current is flowing through it, and we don't want it to affect the actual circuit or what's going on in the circuit, it has to have a very, very low resistance. Very low resistance. Because the more resistance this guy has, the more he's going to affect the actual current coming out of the battery. So we don't want the device that's measuring the current to actually affect the flow of the current, if that makes sense. Okay, so long story short, you have to know two things. They're hooked up directly on the wire so that the current could flow through them, and they have very, very low resistances. Okay. The next one is a voltmeter. This one's a little bit trickier, so try to hang with me here. A voltmeter measures the potential difference. So basically, as the current comes out and gets here, we want to find out how much voltage is dropped, the change in the voltage between the beginning of this device and the end of this device. So it says it's connected across a section of a circuit, usually across an electrical device. So in this case, we have it hooked up across a resistor. So it says because it measures potential difference, it needs to measure the potential before the current reaches the device, so here, and after it's gone through the device, so here. So it can find the difference between what it was before and what it is after. Okay? Now, to keep the current from getting here, and it's not something we've officially talked about yet, but definitely something we're going to spend a lot of time on tomorrow. It keeps the current from getting here and saying, wow, I want to go this way instead, because it's probably an expression you've heard before, but current always flows the path of least resistance. So, if it has the option to go this way or this way, we want it to make sure it stays in the circuit. We want it to go here. So, how are we going to go about doing that? Well, we have to make the voltmeter have a tremendous amount of voltage, a tremendous amount of resistance. So, this guy, as it says down here, has very, very high resistance. So, again, long story short, what do you need to know about this? You need to know that a voltmeter is hooked up on either side of the device we're checking the voltage of, or the voltage drop on, and we have to know that it has very high resistance. Okay, the last one, real simple, is a switch. A switch is drawn exactly as it works. So a switch is a way of starting and stopping the current flow through a battery. So if the current is coming out here and going through these lamps, now these lamps are drawn a little bit differently than they are on your reference table, but if you were to ever actually look at a blueprint for a home or an office or something like that, this is actually the way they draw lamps. Okay, so this is more of a blueprint picture. Now, this here, this switch, is open, which means if the current got to here, it can't go any further. So there would effectively be no loop. And without a loop, there is no current. Okay? So when the switch is open, no current can flow because there's no closed loop. So it has no way of getting all the way over here. If it were closed, so if we, forgive me, I know I keep erasing this. So if I were to close the switch, which would just be put it in this position, well now it makes for a complete loop. So when it's open, no current flows. When it closes, it just completes the loop and it allows current to flow. All right? So This was just a real simple, quick lesson on these three devices. So we got the ammeter, we got the voltmeter, we got a switch. The reason I wanted to do this today without the pressure of putting any actual assignment attached to this is I just really want you to take some time. I want you to look this over, maybe even copy these notes down. And this way, when tomorrow we start talking about parallel circuits, which is just going to be a slightly more complicated version of series circuits, we'll have these things to actually work with. I assure you, knowing these things will actually make your life easier when we get into parallel circuits. All right, well, hopefully that wasn't too painful, and I hope you enjoy your Tuesday. I'll see you guys tomorrow.